Okay, guys, we meet again in our session. Okay, so for this session, I will try to explain a little bit about the Newton's universal law of gravitation. So before this, we have look into the gravitational force. Okay, what is the gravitational force? Gravitational force. So it is a force between two objects A and B. Let's say object 1 and object 2 in universe. Okay, in universe a force existing between the two objects in universe, no matter what size of the objects. Okay, no matter what is the mass of the objects, as long as we have the two objects in the universe, so there must be a gravitational force. So let's say we have electrons and nucleus. Okay, nucleus. So we have two objects. So there must be gravitational force. Or we can say if we have a black hole with the what? With the stars. Okay, stars. So there are always gravitational force. So that is all about gravitational force. So for today, we look into the more specific into the Newton's universal law of gravitation. Okay, how the physicists come up with the equation of the law itself. So before come up with the law, Newton's had formulated. Okay, Isaac Newton's had formulated two relationship. Okay, relationship to tell about the gravitation force. Okay, so the first one, okay, the first relationship, Newton said that the gravitational force, okay, let's say we just put Fg, okay, Fg for gravitational force. The gravitational force itself, whenever we have the two objects, objects 1 and object 2, okay, is directly proportional. Okay, is directly proportional. So this is the symbol that we use for directly proportional in mathematics. So it's directly proportional to what? To the product. Okay, is directly proportional. Okay, let's say let me write it in sentence first. Okay, so gravitational force is directly proportional, which means the force or gravitational force will increase at a fixed ratio to what? Is directly proportional to the product. Okay, to the product. So when we find this, or when we saw this term, the product in mathematics, normally it is the product of multiplication. Okay, product of 2 and 3. What is the product 2 and 3? It is equals to 2 times 3. Okay, so the product here is the product of multiplication, proportion to the directly proportional to the product of what? Of the mass, okay, of the masses of the two bodies, two bodies, okay, bodies lah, okay, bodies. So that's mean Fg, or the gravitational force between mass 1, between object 1 and object 2, or body 1 and body 2, is directly proportional, will increase at a fixed ratio, depends on the mass of these two objects. So if we write it in mathematical term, Fg, or in proportionality, is directly proportional to the product hasil darab M1 and M2. And normally for the product, we just put it as M1 dot M2. Okay, so this is the first relationship formulated by Newton. Okay, gravitational force depends on the product of the M1 and M2. Okay. For the second, okay, for the second formula, okay, or second relationship, Isaac Newton tell that the gravitational force is inversely proportional, okay, is inversely proportional, okay, when we say that inversely proportional, we must put this sign for fraction, okay, fractional. So inversely proportional to what? Inversely proportional to the R square, okay, to the R square. What is R square? So R is the distance, okay, distance between sorry, okay, yes, R is the distance between the center of the two bodies, okay, of the two bodies. So let's say we have two bodies, bodies 1 and bodies 2, okay, bodies 1 and bodies 2. So from its center, we measure the distance, and we will get R. And then Newton said that the gravitational force Fg is inversely proportional to the square of the distance, to the square of the distance. Don't forget the square. So if we write it in sentence, so gravitational force is inversely proportional to the square of the distance, okay, the distance between the center, okay, always measure from the center of the bodies, so that are the two relationship, okay, the two relationship given by Isaac Newton. And then if we combine these two, if we try to combine these two relationship, we will get, okay, if we use to mathematics equation, so the gravitational force is directly proportional to the product of the two masses M1 and M2, and at the same time it also inversely proportional to the square of the distance. So this is the final proportionality which later we use for an equation for the Newton's law of gravitation. Okay, so this is the final proportionality, and then we can use this final proportionality to tell about the Newton's, okay, Newton's universal law of gravitation, okay, of gravitation. So from the relationship, we can see that, okay, what had been stated by Newton's universal law of gravitation. So Newton's universal law of gravitation state that, the gravitational force, okay, I just use the symbol Fg here, the gravitational force between the two bodies, body 1 and body 2, is directly proportional to the product of both bodies of the masses of both body and, okay, here we include the second relationship with the first relationship. So they will be combined in one relationship, and this relationship will be used as Newton's universal law of gravitation. And inversely proportional. Inversely proportional. To the square. To the square. Don't forget the square of the distance. Distance of what? Distance. Okay, distance between the center. Always measure from center to center. Between the center of the voice. Okay, so that is all about the Newton's universal law of gravitation. And then from the relationship, okay, from the relationship, okay, just like mathematics, if we want to change proportionality into equation, we just put a constant. So Fg equals to, okay, now we change the sign, proportionality to equation, okay, equals to, okay, just copy the relationship first, M1, M2, R2, and then put a constant. So for this purpose, for gravitation, the constant that we use is G, okay, which we call as, what is G? What is capital G? It is the gravitational constant. It is always a universal constant. That means the value remain the same. So the value always equals to 6.67 times 10 to minus 11. And the same unit, of course, nm 2 kg minus 2. No matter what the problems are, no matter where you are, okay, although you are dealing with electron and nucleus, or you are dealing with galaxy and planets, so this is the value of G that you want to use, okay. Don't change this value, okay, it remain constant. That's why we call it as universal constant, okay. So that is gravitational law, Newton's universal law of gravitation. Okay, later we look into the next video, which we look into calculation. Okay, calculation involve the law or the equation, okay, so that we can further understand how to use the equation in a real life. Okay, that's all. Thank you.